All right, section 5.3 talks about normal distributions and finding values. So it says in the previous section, 5.2, we were asked to find the probability that a random variable x lied within a given interval by calculating the z-score and determining the area under the curve. Sometimes, however, we're given a probability, and instead we need to determine what z-score, and by extension, the variable value that leads to that probability. Okay, so what we're going to do here, we're going to find a z-score that corresponds to some of these areas. So guys, I'm going to show you two ways to go about doing this. So the directions here say, let's find a z-score that corresponds to a cumulative area of 0.4761. So I'm going to pull up my chart here, and I'm going to look at all these little values that we have here, okay? Look through all those little values, and give me 1 second. Let me see if I can do this here. And boom. Okay. Let me make sure that it's doing that. Yes. Okay, so now I'm going to look for all these little values, and I'm going to try to figure out, do I see one that says 0.4761? And I believe I do. If I look right, oops. Yeah. Oops, let me trying to get rid of this little menu down here. Yeah. If I look right here, there's 0.4761. And what is the z value? It looks like it's going to be negative 0.06. So then I would come back over here and I would say z is equal to negative 0.06. And so the first thing some of you might notice is like, wow, I have to look at all those different values and see if I can find one that looks like this. Well, that's one way you can do it. Another way you can do it is using your calculator. So let me clear the screen, right? If I want to find this, I'm going to go second vars. And I want you to look at the third one. It says inverse norm. So inverse means I'm going to be going backwards, okay? So I'm going to go to inverse norm. I'm going to hit enter. And I'm going to type in that 0.4761. Close off my parentheses. I'm going to hit enter. And if I were to round that number to 2 decimal places, I'd be coming up with negative 0.06, which is exactly what we got right there. Okay. So I'll do the same thing here. We're going to find a z-score that corresponds to a cumulative area of 0.05. Okay, 0.05. Let me make sure that's the right number that I saw. Yeah, 0.05. 0.05, 05, 05, 05. Okay, so if I look right here, guys, if you look at these two numbers, the number in the middle would probably be that. Because this is 0.495 and this is 0.0505. So right in the middle would be 0.05. So if this is negative 1.6 and I'm between 0.5 and 0.4, I might say something like 1.645. Negative though. I was forgetting something. Negative right there, right? And again, if I wanted to use my calculator, I would just go second vars, inverse norm, type it in, right? 0.05, close it off, hit enter, negative 1.645, right? Okay, let's take a look at number 3. Number 3 says, find a z-score that has 12.71% of the distribution's area to the right. Okay, so I want to think about this for a minute. Okay. So it's telling me that the area to the right is going to be 12.71%. Remember, as a decimal, that's 0.2171, right? So remember, my table always tells me the area to the left, right? So if I wanted to figure out, well, what would the area to the left be, I could say, well, let's find 1 minus 0.1271. 1 minus 0.1271. Hit enter. And that's giving me 0.8729. Okay. And so if I were to come back and use my chart, 0.8729, I'm going to have to scroll down a little bit. 8729. 8729, maybe not that far. Let me see if I can find it. And I'm just trying, here we go. Y'all see it right here in the middle? So 1.14. So I'd come back over here and I'd say, okay, my z value is going to be 1.14. And if you wanted to use your calculator, you could go, let's go second vars. and we're going to go to inverse norm. And I'm going to type in 0.8729, close it off, hit enter, and 1.14. Okay. So again, guys, I want you to know that you can do these problems, again, either using your calculator or using the table, and whichever one you find easier to use, then that's one that I want you to use. Okay. Let's take a look at problem number 4. Problem number 4 says we're going to find a z-score for which 75% of the distribution area lies between z and negative z. Okay, so let's think about what that means. We're going to have two values. One's going to be negative z, one's going to be positive z, and the area in the middle is going to be 0.75. Okay, we're looking for these values here. So remember, the area under the whole curve is 1. So if I say what's 1 minus 0.75, that would be 0.25, right? Like 25 cents. But wouldn't that tell me that if I were to take this number and divide it by 2, that would give me 0.125, because that would actually be the area in these sort of blue curves here, 0.125, right? And 0.125. So if I knew that the area to the left here is 0.125, what would this number here be? Well, my guess is it's going to be negative because it's over here to the left, right? So I could do my calculator. I can say, let's go second vars. Let's go to inverse norm. Enter 0.125. Okay, close it off. And I'm coming up with a negative 1.15. So the first value is a negative 1.15, right? Okay. And so, guys, if I was looking now, say, for this value, okay, well, think about all the area here. Wouldn't it be 0.75 and that one as well? So I could say, what's 0.75 plus 0.125, okay, 0.875, and then I can go second vars, inverse norm of 0.875, and if you look, coming up with positive 1.15. So the other value would be positive 1.15, right? And we found our two values. Okay. Let's take a look. So number 5. Number 5 says, find the z-score that corresponds to each percentile. Okay, so part A, P8. All that means, let me show you what this means. I'm going to draw a very quick graph. It's telling me that, remember, here's my 0, right? My z-value of 0. It's telling me that the area to the left here is going to be 0.08. Okay. So one thing I can do if I want to, grab my calculator, 0.08. Before I look at my table real quick, I want you to think about my z-values, right? My z-value here is 1, 2, 3, right? Negative 1, negative 2, negative 3. I don't necessarily mean that it's going to lie right there, that the answer is negative 2. But what I want to point out is when the area to the left is 0.08, look at the kind of z-values I'm getting. Getting negative z-values, right? So when I see this part right here, and these are all positive z-values, that's like, that's not going to be right. And I'm looking for when the area to the left is 0.08. 0.08, right about here. So my guess would be about negative 1.4, right? That would be my guess. So my z-value, I would say, is about negative 1.4. If I decided to do this on the calculator, I would just go second vars, inverse norm, 0.08, close it off, and I should be coming up with something close to that. Negative 1.41, right? So again, I'm coming up with the answers. Either way I'm doing them, they're making sense. And drawing this little picture right here, guys, to me, is super helpful because it gives me an indication of where my answer should be, okay? So look, let's take a look at part B. Part B, I'm going to draw my graph again, right? Okay. Remember that's 0, and then there's 1, 2, 3, -1, -2, -3, right? Okay, part B says, can we find P25, right? Remember, we're looking for what Z value tells me that the area to the left of the curve, or to the left, underneath that curve is going to be 25%. So remember, we said the area under the whole curve is 1. If the area under the whole curve is 1, wouldn't this area here be 0.5? And if I'm looking for when is the area going to be 25%, wouldn't that be, oops, let me get a different color. Wouldn't that be somewhere in this region? But my point is, I know that my answer is still going to be negative, right? So I've already used my calculator again. Second bars, inverse norm, hit enter, hit 0.25, close it off, and I'm coming up with a negative 0.67. So Z equals a negative 0.67, right? And then there's a part C. Part C here says the area to the left of our curve is going to be 0.95, right? So again, 0, 1, 2, 3. My answer is going to be positive because it's telling me, look, the area all the way over here to the left should be 0.95. And I know the area under the entire curve is going to be 1. So if I come back over here, grab my calculator, second bars, inverse norm, right? Hit enter, 0.95, close it off, hit equals, and I'm coming up with 1.64, right? And you say, okay, how would I do that on my chart? The same way. So let me scroll, 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 and I'm looking for 0.95. 0.95, 0.95. So again, probably right between those two. So 1.64, 1.645 is probably what I would again guess. I would have said 1.645. But again, notice we're coming up with really close values, right? Okay, so let me scroll down a little bit more here. And now it says, let me just erase this so we can see everything. Here we go. Okay, transforming a z-score to an x value. Just as we transformed x values in a non-standard normal curve to z-scores on the standard normal curve, we can transform z-scores from the standard normal curve to x values on the non-standard normal curve. Okay, so it gives me a little formula right here. This formula is going to be helpful. We're going to use it because it's right there. So let's take a look. It says, to transform a standard z-score to an x value in a given population, use this formula. So number 6 says, a veterinarian records the weights of dogs treated at a clinic. The weights are normally distributed with a mean of 52 pounds. Okay, so the first thing I'm going to do, my mean is 52 pounds, and my standard deviation of 15 pounds. Okay. Find the weights x corresponding to z-scores of negative 2.33, 3.10, and 0. Okay, so we're looking for the weights x. So let's do this one. I'm going to call it like this, x1. x1 is going to be equal to, let me use my formula right here, mu plus, I'm going to call it a z1 times sigma. Okay. The reason I'm using 1 because I have 3 values there. Okay. So we said our mean was 52 plus the z value that they gave us is negative 2.33 times, let me, instead of putting another parentheses, let me just go like this, times 15. Okay, so guys, I'm writing it this way just so you can see how I'm going to do this on my calculator. Remember when we were back in like 8th grade and you had order of operations? We got to do what's on the inside of the parentheses first. So I'm going to say negative 2.33 times 15 equals, and then we're going to add 52. Okay. So this particular dog weighs 17.05 pounds, right? Okay. I want you to think about this dog. Look at this dog. The average weight of the dogs was 52 pounds with a standard deviation of 15. Okay. So what that would mean, if you kind of think about that for a little bit, we're going to say 52 pounds would kind of be in the middle. And then if we subtract 15, that would be one deviation away. And if we subtract 15 again, that'd be another deviation away. And if we subtracted 15 again, that'd be another deviation away. So we know that this dog, compared to the average, weighs much less, right? And because he weighs much less, look at his z-value. His z-value was a negative 2.33, right? Because he weighed much less. So he was 2.33 deviations away from the mean. Okay. Now I'm going to scroll over here so I can do my x2. Okay. So x2 is equal to mu plus z2 times sigma. Okay. x2 equals, let me see, we already knew that this was 52 plus, what was the second z value that we had? I think it was a positive something or another. Positive 3.10, looks like right here. Okay, positive 3.10. So, oops, that's too far. Here we go, 3.10 times my standard deviation of 15. Okay, so I'm going to grab my calculator again. Let me just move it over this way. And I'm going to say, okay, what's 3.10 times 15 equals plus 52. And this dog weighs 98 point, how much? 0.5 pounds. That's a big boy, right? Or a big girl. But we got a big dog here, right? Notice again, remember what we said? We said that the average was 52 pounds, right? So if we added 15, that would be one deviation away. If we added another 15, that'd be two deviations away or above. If we added another 15, that'd be three deviations away. Notice what this is, 3.10. So this dog is more than three deviations away from the mean. So this dog that's why he weighs so much, right? And then we had a third one, x3, which would be equal to mu plus my third z-value times sigma. And I'm pretty sure that our z-value here was 0 times 15. Well, 0 times 15 is 0, plus 52 is 52. So that dog weighs the same as the average, right? That dog is 0 deviations away, right? He is exactly, or she is exactly the same weight as the average of all the dogs. Okay. So let me move back this way so we can finish off what we have here. Okay. Let's see. Number 7 says, in a survey of men ages 20 to 29, the mean height was 69.4 with a standard deviation of 2.9 inches. Okay, so let's write this down. My mean, 69.4 inches. My standard deviation is 2.9 inches. Okay, this is important information, so I'm writing it down. Now it says, what height represents the 90th percentile? So again, what I want you to think about, let's draw my picture here. There we go. 90th percentile. Okay, that means that the area to the left of this curve is 90%. First thing I need to do, I need to find that z-value. Okay. So my z-value, I'm going to come back to my calculator. I'm going to go, let's go second bars. Let's go to the inverse norm. We know the area to the left is 90%, 0.90. Okay. What is the z-value that I have here? 1.28. Okay. So my z-value is 1.28. Okay. So now what I'm going to do, I'm going to find my x value. Okay. My x value is going to be the mu, the average, plus my z-value times my standard deviation. Okay. So our average was 69.4 plus my z-value, we just found that to be 1.28 times our standard deviation of 2.9. Okay. So again, I'm going to do this on my calculator. I got to do what's on the inside of those parentheses first. So let's take 1.28 times, what is that, 2.9 equals, okay. And then I'm going to add 69.4. And I'm coming up with 73.112. 73.112. This is the height, and the height was given to us in inches. Okay. Now there's a part B. Part B says, what height represents the first quartile? The first quartile, guys, is the same thing as 0.25. That's to tell me that the area to the left is 0.25. What I want to do is we want to find what is the z-value. We don't need to call it z1, we're only finding one. What is the z-value that corresponds to the area to the left being 0.25? So let's go second bars. Let's go to our inverse norm, hit enter, go 0.25, close it off. Okay. Should get a negative number, negative 0.67. So negative 0.67, okay. Now, I'm going to use the same formula that I have right here, okay? So I'm going to write it out. X equals mu plus z times sigma. And I'll write it over here because I'm running out of room. So X equals mu, which we said was 69.4, times the z value was a negative 0.67 times sigma was right here, 2.9. Okay. So let me do this on my calculator. I'm going to clear it out, negative 0.67 times 2.9 equals plus 69.4 equals, and I'm coming up with a height of 67.457. So 67.457 inches, right? Boom. There we go. All right. So, question number 8. Says, scores on an exam for an entry-level position at a reputable firm are normally distributed with a mean of 50. Okay, so let's go like this. First thing we know, the mean is 50, standard deviation of 10. It says the firm will only hire applicants with scores in the top 10%. What is the lowest score an applicant can earn and still be eligible to be hired by the firm? Okay, so let's think about what they're telling us. Here's the area of my curve, right? Or here's my curve. They're saying they're only going to take people who score in the top 10%. So that means the area underneath that curve is 0.10. So then wouldn't that tell me that the area to the left of it would be 0.90? And if I was trying to find what is that value on my z table, when the area to the left is 0.90, then what I would do is I would grab my calculator and I would say, let's go to second bars, and let's go to, inverse norm, okay? And I'm going to type in 0.90, okay? Close it off. And my z value that I'm getting is 1.28, okay? So my z value here would be 1.28. Now, guys, the one thing I want to mention is that the reason why I'm always interested in the area to the left this way is, number one, if I use my chart, it always tells me the area to the left. If I use my calculator to do my inverse norm, it's always telling me the area to the left, okay? So that's why I'm always concerned about my area to the left, all right? So I just wanted to give you a heads up on that. So now we found our z value to be 1.28. So we're going to use our little formula here. X equals mu plus z times sigma, okay? So the mu in this case was 50. My z value is a 1.28, and my sigma was 10, okay? And so I'm going to grab my calculator again, and I'm going to say, what's 1.28 times 10? It's that. And then we're going to add 50 to it. Okay. So the lowest score that somebody can earn is a 62.8. Okay. This would be the lowest score somebody could earn and still be in that top 10%. All right? All right, so let's take a look at the last problem that I got here out of 5.3. It says the weight of bags of baby carrots are normally distributed with a mean of 32 ounces. Okay, so that's important. My mean is 32 ounces and a standard deviation of 0.36 ounces. It says bags in the upper 4.5% are too heavy and need to be repackaged. It says, what is the most a bag of baby carrots can weigh and not need to be repackaged? Okay, so let's think about that. First thing I'm going to do, I'm going to draw this graph. Okay, it says bags in the upper 4.5% are too heavy. 4.5% as a decimal, guys, is 0.045. What that's telling me is that the area over here is 0.045. So if I wanted to find, say, the area to the left, I could say, well, what's 1 minus 0.045? So if I said, what's 1 minus 0.045, I'm coming up with 0.995, or 0.955, I'm sorry. So 0.955, that's telling me the area over here to the left. So what I want to do is I want to figure out what is this z value going to be. So let me grab my calculator again. Second bars, inverse norm, 0.955, close it off. Okay, and I'm coming up with 1.70. If I were to round that to 2 decimal places, I'd end up with a 1.70. Okay, so now what I want to do is write out my formula. X equals mu plus z times sigma. So my mu in this case was 32. Our z value we came up with was 1.70 times my sigma, which is a 0.36. Okay, so I'm going to grab my calculator. First thing I'll do is what's 1.70 times 0.36 is 0.612, and then when I add 32 to it, it's 32.612. And so that's the most that a bag can weigh before we need to repackage it.